Welcome to today's lesson, students. So far, we have discussed the thermal expansion that is observed in solids, and we have discussed many different instances where we utilize thermal expansion seen in solids, as well as due to thermal expansion in solids, the precautions or whatever the methods that are utilized in order to prevent the effect caused by thermal expansion seen in solids. So now I am going to discuss expansion of liquids again due to heat. So here we discuss an activity. Activity illustrate the expansion of liquids. So for that, these are the materials that are needed. We need a test tube, or you can even use a boiling tube. Test tube or boiling tube can be used. Then we need colored water. We need a Bunsen burner. In addition to that, we need a glass tube. Then we need a beaker or a glass vessel. Glass vessel. And we need a stand with clamp to clamp the test tube. So students, these are the materials that we need. A test tube or a boiling tube. We need colored water, and you all know why we need colored water. Colored water, it helps us to observe the change in water level easily. So we need a Bunsen burner, a glass tube, beaker or a glass vessel, and also we need a stand. So those are the requirements or the materials required to do this activity. I will move on to the next slide where we can discuss how we are going to do this activity. So this is how we do the activity, the method. So here you can see, students, the diagram is shown to you. So inside a test tube, we take colored water. Normally you all know the reason for using colored water. When it is colored, it's easy to observe the change in the liquid level. And also we need to have a stopper here. So this is going to be the stopper. And you can see the glass tube is inserted there. So when you insert the glass tube, it will rise up. Then you can see there is the liquid level, and this liquid level will change on heating or cooling. So that is what we are going to observe now, because we are going to observe the thermal expansion caused in liquids. So if we say expansion, the volume of liquid has to increase so that the water level has to increase. That is what we have to observe now. So fill a test tube with colored water and fix a rubber stopper with a glass tube to the test tube as shown in the figure. Mark the water level on the glass tube. So you have to mark the level. The yellow color line there, you can see that is to mark the water level on the glass tube. Insert the glass tube in a warm water vessel for a few minutes and examine it. So that is what we have to do here. We have to insert the test tube into a vessel containing water that is warm. So here it has to be warm water. So then what will happen? The heat from warm water will be given to the test tube and the water, colored water contained within it. So due to that temperature, increase in temperature, the liquid will expand or the water will expand. So you will have to observe a rise in water level. So we have to observe this level very carefully. That is the activity that we need to do. It's a simple activity. So let us go to the lab and do the activity first. Okay, students. So now we are going to do this activity in order to observe how liquids expand on heating. So thermal expansion of liquids. So for that I have prepared the setup here. You can see there's a beaker containing water. Inside that you can see the test tube with colored water, and there is a cork attached to the mouth of the test tube, and into the cork there is a tube inserted. You all know the reason why we use colored water, so that it will be very easy to observe the change in liquid level. And in addition to that, as you can see here students, I have attached a pointer to the setup, so you can see the initial level of the liquid. So then on heating, you will be able to see whether the liquid level rises up or goes down, or whether both happen, and whatever the changes that can be observed very clearly. So with that, I will light the burner, then you can see what happens in this activity. Okay students, now that the heat is being supplied, observe what happens to the water level inside the tube. So observe the tube students. You will see a slight decrease in the water level inside the tube. Can you observe that? The level has decreased a little bit. So a slight decrease will be there. After that, observe. Now you all can see the increase in water level inside the tube. So what happens there, students? Initially, when the water inside the beaker becomes hot, the heat is transferred to the test tube, and first the glass test tube expands. Because of that, water level decreases inside the tube here. Thereafter, the increase or the expansion of glass stops, and after that, the colored water inside the test tube starts expanding. That is why you see the increase in water level now. So can you all observe the expansion of liquids due to heat? That is thermal expansion of liquid or thermal expansion of water. You can see clearly the rise in water level inside the tube. Okay students, so you were able to observe what happens there. Initially we had the tube, this is the setup that we made, then we fix it to the stand and we insert it into a beaker containing water, and then we heat the beaker. So when we have the Bunsen burner flame, it's burning, the heat is provided to the beaker plus water, so that becomes warm, and from there the heat is conducted or it is transferred to the test tube containing water, and there is expansion in water. So here students, if we look at the observation there, now this is the thin glass tube that we used, and in that, initially the water level is at point A. And if we get the observation properly, first the water level will decrease to point B, and thereafter it will increase to point C, and if you keep on heating it, the water level will keep on rising to a certain point. What is the reason for this? Now when we provide heat, as I told you, heat is transferred to the test tube containing colored water. First the test tube will absorb heat, and test tube you know is made up of glass, so that also undergoes expansion. So initially the volume of the test tube increases. Then of course the water level inside the tube will decrease. Why? The volume of water is the same, but the volume of the test tube increase. So because of that, the water level decreases and comes to point B. Thereafter, when water inside the test tube becomes hot, it starts expanding, and the expansion is more than the expansion of the test tube. So because of that, you see the water level rising inside the glass tube. So that is what happens in this activity. So initially, due to the expansion of the test tube, water level decreases. But then the expansion of colored water is greater than the expansion of the test tube. Therefore, you see the rise in water level inside the glass tube. So the observation is written to you. Water level drops slightly down to B and rises up to C back again. So that is the observation. So I will write down the conclusion of this activity. So initially, water level decreases, or you can say drops, to point B due to the expansion of the test tube. That is glass. Then the colored water expands. This is more than the expansion of the test tube. Therefore, water level rises in the thin glass tube. So from this, we can conclude and say it can be concluded that water, or in other words we can say liquids, expand on heating, or you can say liquids also undergo thermal expansion. I am sure you all can understand that. So then, if I move on to the next slide. So in this experiment, first the test tube expands when the temperature of the water increases. So I explained all these to you all. Initially, the test tube expands, so the water level decreases. Then the liquid level drops down slightly. So why? The volume of water is the same, but the glass expands, the volume of glass, that is the test tube, increases. Therefore, the water level decreases. That is from A to B. However, when the liquid inside the test tube heats up, the liquid also begins to expand. So, thereafter, liquid here means water, that is the colored water inside the test tube, and the glass tube, that also starts to expand on becoming hot. When the expansion of the liquid exceeds that of glass, the liquid level rises again. That is where from B, the liquid level rises up to C, and thereafter when we did the activity you saw, it can go up further. When making thermometers, thermal expansion of liquid is commonly used. So, we have discussed many different types of thermometers. Under that, the first two types, the glass mercury thermometer and the glass alcohol thermometer. In both these, we use a liquid. So, the expansion of liquid is what is used to measure the temperature. So, in mercury and alcohol thermometers, the expansion of liquid volume is used for measuring temperature. So, if you can remember students, when we discuss these thermometers, we discuss why these two liquids were taken as suitable for thermometers. And there we discussed that they show uniform expansion over a broad range of temperature. So, over a broad range of temperature, they expand and that expansion is uniform. That is why it's easy to use these liquid to indicate the change in temperature. So, that is one important application of thermal expansion of liquids. Is that clear to you? So, this is an instance where we use the thermal expansion of liquids in thermometers. So, here you can remember mercury and alcohol expand uniformly over a broad range of temperature. And here also students, you all can remember mercury thermometer is useful in measuring very high temperatures above 100 degrees Celsius, whereas alcohol thermometers is very useful when it comes to lower temperatures, minus values in degrees Celsius. So, both thermometers have liquid in them and the two liquids, they show uniform expansion or they expand uniformly over a broad range of temperature. Because of that, they are very useful in thermometers, and that is one important application of expansion of liquids due to heat. So, with that students, I will move on to the next slide where we discuss expansion of gases. Again, to understand expansion of gases, we will be doing an activity to illustrate the expansion of gases, and these are the materials or the requirements that we need to do this activity. We need ice cubes or ice. Then we need a glass bottle, a balloon, in addition to that, we need hot water, and we need 2 vessels. It can be glass vessels or metal vessels or even beakers can be used, no problem. So, this is what we will be doing. Initially, we will take ice into a vessel and into that we will insert the glass bottle and then we put the balloon over the mouth of the glass bottle, and at that instance the balloon is not inflated. Thereafter, what we do is we transfer the glass bottle into an empty vessel and into that we will need to pour hot water, and then you need to observe what happens to the balloon. And after that you can take out the glass bottle with the balloon and again keep it inside the vessel containing ice as well, ice cubes and ice water together. So, then you can observe what happens there. So, by doing this activity, you can observe both expansion of air as well as contraction of air. So, that is the activity. Again, I will discuss the method. This is what I explained to you all students. Initially, we have ice in a container. So, the bottle is placed inside the ice and the balloon is attached. Thereafter, we transfer it into a vessel containing warm water or keep the bottle inside a vessel and then you can pour warm water. Either way is fine. There you can see the inflation of the balloon. And again, if you take the glass bottle and place it back in ice, you can again observe the contraction of the balloon. The contraction of air that is observed by the deflation of the balloon. So, place an empty plastic bottle without a lid vertically in a vessel containing ice and water for a short while. So, ice and water you can't have only ice, or even if you have only ice, it's okay. But ice and water means there will be uniform cooling. So here ice and water for a short while. Then attach a balloon to the opening as shown in the figure. Next, place the bottle in another empty vessel and pour hot water into the vessel as shown in the figure. Observe the balloon when placed in ice again for a while. So, first in ice, then in hot water or warm water, again back in ice. So, you can observe what happens to the balloon. So, again it is a simple activity. Let us do the activity in the lab. Okay, students. So, now I am going to do this activity to demonstrate the expansion of gases with heat. So, for that I have a glass bottle to which I will be fixing this balloon, and inside this beaker there is ice, and I have this glass container into which I will be pouring some hot water. So, first what we need to do is we need to place the glass bottle inside the So, here I have kept it inside ice, and I will rub a balloon over the mouth of the bottle, and if we let it for some time like this, you will see that the rubber balloon will shrink. That is because the air inside the glass bottle will contract due to the cool ice here, and because of that the volume decreases and the balloon will shrink. So, while that is happening, I will take some hot water into this. So, now students, first I will place this glass bottle inside warm water. Then you all observe what happens. I'll have to observe the balloon. Here students, you all can observe the balloon. It's getting inflated little by little. It takes a little time, but still you can observe. You can see the inflation in the balloon. I will add a little bit more water. So now you can see it more better. Although it's taking time, it will inflate. So why does this happen? When we place it in hot water, the glass bottle gets the heat, and from there the heat is transferred to the air inside the glass bottle. Due to the heat, the air inside the glass bottle expands, and when that expands, it comes up and fills up the balloon. So that is why the balloon inflates. So now still you can see students, little by little the balloon is getting inflated. Okay students, can you all see it becoming more inflated now? When compared to the previous stage, the balloon has inflated to a certain extent. So now here you can see, students, the balloon has inflated nicely. So that is because of the expansion of air inside the glass bottle. Now if we take this glass bottle and place it again inside the ice, you can see the contraction of the balloon. Now see, immediately it has gone down. And again, you can observe the contraction. So on cooling, air contracts, and on heating, air expands. So can you all observe the contraction, students? It's very clearly visible now. So here you can see this is again a reversible process. On heating, air expands, and on cooling, it contracts. Same goes for the other states as well. So, okay, students. So, initially when we placed the bottle inside ice, the balloon was shrunk. After that, when I transferred it into hot water, the bottle was kept inside hot water. Because of that, the air expands, and then you were able to observe the inflation of the balloon. Again, now I have placed it back in ice. You can see the contraction of the balloon. So, from that, you can clearly understand, due to heat, air expands on heating as well as it contracts on cooling. Okay, students. So, did you all observe what happened during the activity? Yes. So, initially we had the glass bottle inside a container with ice, and then we fixed the balloon to it. After that, you were able to observe the balloon getting inflated when we placed it in another beaker, and when I poured hot water into it, you were able to see the inflation of the balloon. And thereafter, when I again transferred the glass bottle with the inflated balloon back into ice, you were able to observe the contraction of the balloon, contraction or the deflation of the balloon. So that is the observation that you get from this activity. So here, if we write the observations, balloon inflates when bottle is inside hot or warm water. And balloon deflates, or you can say contracts, when the bottle is inside or is kept again inside ice. So that is how you get the observation. So from this observation, students, what can we conclude? Why did the balloon inflate? Because the volume of air inside the glass bottle as well as balloon increases. So how does that happen? Now here, when you place the bottle into ice, the air has a certain temperature, that is a low temperature. And when you transfer the bottle into hot water, vessel containing hot water, initially the heat is absorbed by the glass bottle. So there also the glass bottle will expand a little bit, but from the glass bottle, when heat is transferred to the air inside it, air becomes hot, and due to the heating up, air expands. So when it expands, the volume of air increases. So when that happens, the air will be pushed into the balloon and the balloon gets inflated. So that is why the volume of balloon increases, that is the balloon inflates. So that is due to the expansion of air due to increase in temperature. That is one conclusion that we can get. Air expands when temperature increases, or you can say when heated. Then what was the second observation? That is the contraction of air on cooling. So here we can say air contracts on cooling. So when we place the glass bottle inside ice again, the bottle becomes cool first, then again due to the transfer of heat from air to the bottle back to ice, the air inside also cools down. Because of that, the volume decreases and then the balloon deflates. So that is the second conclusion that I have written here. So air expands on heating and it contracts on cooling. That is the conclusion of this activity. So students, this is one of the activities that is used to observe the expansion of air. Now I will move on to the next slide. So when the bottle is placed inside the ice vessel, the temperature of the air inside the bottle is close to 0 degrees Celsius. So in the vessel we had ice and water. So that means the ice is at its melting point, that is 0 degrees Celsius. So because of that, the bottle and the air inside the bottle also becomes cooler. But there we cannot say that the air inside the bottle is 0 degrees Celsius, but it will be close to 0 degrees Celsius. So maybe 2 or 3 degrees Celsius will be the temperature of the air inside the bottle. But still that is a very low temperature compared to the room temperature. So when it is placed inside warm water, temperature of the cool air in the bottle increases close to the room temperature and the air expands. So there the air in the bottle increases close to room temperature and therefore air expands. This is what we are trying to observe and understand. Expansion of air due to increase in temperature. This air cannot leave the bottle because of the balloon attached to it. So when it expands, normally air tends to rise up. We will be discussing that again under methods of heat transfer. So there when the air rises up, it cannot go out of the bottle because the balloon is covering the mouth of the bottle. So instead what happens is the balloon inflates. So because of expansion of air, the balloon inflates. When the bottle is taken out, the air cools down to the room temperature, shrinking the balloon again. So we can conclude that the air inside the bottle expands when it heats up and contracts when the air cools down. So this is what we need to know. Expansion and contraction of air. Expansion on heating and contracts when air cools down. So far we have discussed the expansion and contraction of substances, solids, liquids and gases. So this is one activity that can be used to observe the expansion of air. After this, I will be discussing another activity, a simple activity that also can be used to observe the expansion of air on heating. So activity illustrate the expansion of gases. So for that, these are the requirements. We need hot water. Again, we need a glass bottle. And here we will be using a coin, and the size of the coin has to be the size of the mouth of the bottle so that you can place it on the top mouth of the bottle and it has to cover the mouth. Then only you will be able to observe what happens there. So, I will move on to the next slide where we discuss the method. So, place the glass bottle inside a vessel. So, you need to have the vessel here. You will have the glass bottle like this here. And then we take a coin, we wet it, you dip it in water. The reason is, students, when you take the coin, you can remember all the coins, they have designs, marking on either side. The two faces of the coins have the marking. So, because of that, the surface is not flat. So, when you just keep the coin on the bottle, there can be spaces through which air can escape out. So, you won't get the proper observation. To avoid that, you dip it in water so that it becomes even. After that, you place the coin over the mouth of the bottle. So, coin is here. Thereafter, what we do is, we pour water, hot water into this. So, here we pour hot water. And then you have to observe what happens to the coin. So, place the glass bottle inside a vessel, dip the coin in water, place the wet coin on the mouth of the bottle, that is this, then pour hot water into the vessel and observe the coin. Again, a simple activity. Let us go to the lab and do the activity now. Okay, students. So, now we are going to observe the expansion of gases. We already did one activity with the balloon and you were able to observe the expansion of it, inflation of the balloon. Now here we have another activity where we use a coin, a glass bottle and hot water to observe the expansion of gases due to increase in temperature. So to do that, students, now I have a coin here. You all know in the coin there are these patterns or the value of the coin and everything is marked there. So, because of that, if I place the coin on top of the bottle here, on the mouth of the bottle, it has to be the same size so that air does not leak out. But what will happen is, because of those markings there is a possibility that air can leak out. To avoid that, what we will do is, I will place this coin in water. So, those gaps will be filled with water. Then I will place it on this bottle. After that, I am going to place the bottle inside the beaker. And then I will pour some hot water. You all have to observe what happens. Right. So, I will pour the water in. You all have to observe what happens to the coin. I am adding some more water. So, students, you all can see that the coin is getting flipped up and down. So, that's again when the air expands, it pushes the coin up. But what happens is, when the air flows out, again the pressure decreases there, so the coin goes down. Again, when there is an expansion in gas, as you saw now, the coin is being pushed upwards. So, that's due to the expansion of air. So, students, did you all observe what happened to the coin? You were able to see that the coin was being pushed up and it kept on falling back onto the mouth of the bottle. So, that is due to expansion of air. So, what happens there? Initially, we wet the coin, we dip it into water and place it on the mouth of the bottle so that air does not leak out of the bottle. So thereafter we placed it inside the empty vessel, and into the vessel I poured hot water. So what happens there? The heat from the hot water is transferred to the bottle. Initially, you know, bottle will expand, it will increase in temperature, and thereafter the air inside the bottle will absorb heat and the temperature of air will increase. Due to that, air will expand. So when it expands, it will try to escape the bottle. But because the coin is there on the mouth of the bottle, it has to push the coin and try to escape. That is why whenever the air pushes the coin moves up and again falls back onto the mouth of the bottle. That is what you were able to observe there. So you can write that down as the observation. The coin gets slightly pushed up from the mouth of the bottle and falls back. This happens because air tries to escape the bottle when it expands on heating. So from this again, we can conclude and say that air expands on heating. So air undergoes thermal expansion or you can say expansion on heating. So that is another observation that you see, or another activity that is used to explain the expansion of air on heating. So where do we use this? You all have heard about hot air balloons. In hot air balloons, they use a flame. So due to the flame, there is heat generated and the air above it absorbs heat, it expands, and when it expands, like in here, it tries to move up. So when it moves up, it keeps on pushing the balloon along with it. So that is again an application of expansion of air due to increase in temperature. So far we have discussed the thermal expansion seen in solids, liquids and gases. So then in the next chapter, I will be discussing the different methods by which heat is transferred from one point to another or from one object to another object.